Yes. Greetings from WAPP to everybody who has joined us from around the world, and special namaste from my side from India. I welcome you all to the World Association of Public-Private Partnership Professionals Roundtable Playbook. The topic of today's roundtable is digitization of static infrastructure of railroads, the impact on safety, efficiency, and profitability. And to give you a little background, world over, the systems and processes are being converted to automation, digitization. Railroads are no exception. While there are many discussions around the rolling stock digitization, for optimal usage, there appears a need to focus on the static railroad infrastructure, which is equally getting digitized and throwing up unique benefits and challenges. The digitization of static infrastructure in railroads involves integrating digital technologies with traditional railroad infra, such as tracks, signals, bridges, and stations. The digitization of static infrastructure in railroads offers significant benefits in terms of safety, efficiency, cost savings, and customer experience. However, it also presents challenges such as high initial costs, cybersecurity risk, technological dependency, integration issues, data management complexities, and regulatory hurdles. The distinguished panel we have today here is going to discuss the benefits and challenges of digitization of static railroads infrastructure. We have a stellar panel, and we have Mr. BP Avasthi, we have Doris. I will be giving their brief introduction a little later. Phillips and Mr. Rakesh, who's in the process of joining. Before I get on to the actual conduct, uh, allow me to share some webinar technicalities with you and present the sequence of events for the next 90 minutes. But prior to that, let me introduce myself. My name is Dr. Naresh BANA, and I am co-founder at WAPP, that is World Association of PPP Units and Professionals, the global home for public-private partnership professionals. And I also am the convener of Railroad chapter of WAPP. And it's a pleasure to welcome you all once again for this roundtable conversation. So the technicalities are that the duration of this webinar is 90 minutes and it is being recorded. It is scheduled to finish by 16 p.m. CET, that is Geneva, Zurich time. We'll make the recording available on the WAPP YouTube channel. The chat function is activated for organizational matter only. You are requested to use Q&A box for any queries and questions. We'll try to respond during our time together. After a short introduction of panelists, each panelist will answer some thematic questions. The roundtable will last approximately 60 minutes. After the roundtable, there will be ample time for lively exchange with the roundtable participants. Broadly, we are covering 5 questions. That is, what is the pace and status of digitization of static infrastructure globally? What are the safety benefits? What are the gains in efficiency due to digitization? what is the impact on profitability, and what are the challenges in implementation. Now, let's try to answer these questions during this webinar. Let me now come to the introduction of the panelists. First and foremost, we have the lady Doris Chevalier, is recognized for having a combined experience in public and private sector finance. There you are, madam. She acquired her know-how from private companies such as Boyce, Vinci, Alstom, and from banks and investment funds, and from the French National PPP Task Force. She is an expert in the field of infrastructure financing and in particular rail PPPs. She has to her credit an experience of more than 70 projects worldwide, representing more than 20 billion euros of financing. That's quite a bit. Doris has over 30 years of experience in financing infrastructure and renewable energy projects. She is an independent board member of Aéroport de Paris International, the independent observer representing private sector in the Bureau for PPPs of UNECE in Geneva, and an independent member of the EDRAM Investment Committee. Doris. Then we have Mr. BP Awasthi. Mr. Awasthi is a former Principal Executive Director with Ministry of Railways, Government of India. His almost 4 decades of experience with Indian Railways has seen him being part of operations, management, construction, innovations, and digitization of railway systems. He has tenanted almost all challenging appointments in Indian Railways. He spearheaded the digitization of Indian Railways track network, one of the largest network in the world. An alumnus of Indian Institute of Technology, Delhi, he has a master's degree in management and systems from the same institution. He also holds a degree in law from University of Delhi, a railway engineer par excellence. He is a keen golfer and technology enthusiast. Welcome, Mr. Awasthi. And then we have Philip. Philip Markey is a graduate of University of Waterloo, Ontario, with an honors in BSc. He holds a master's degree in business administration from Heriot-Watt University in Edinburgh, UK, and studied transportation geography at York University in Toronto, Ontario. Phil, as he is popularly known, is currently leading Marquez Rail Group as a consultant on rail development and optimization. Phil has over 40 years of railway experience with Canadian National Railway, Illinois Central Railroad, AECOM, and Oman Rail. Phil also initiated and set out the Oman Mineral Line Railway Design and Development Plan and the PPP model. He is currently involved in a railway bypass plan around a major Canadian city and is working on a PPP rail plan in a Middle Eastern country. And then we have Mr. Rakesh Chopra, who's trying to join. There's some technical problem at his end, but let me introduce him. He is a former head of Indian Railway Engineering as member engineering of Indian Railways Board, that is the highest decision-making body. He is well-known personality in the international railway circles, a brilliant civil engineer. He graduated from prestigious Indian Institute of Technology, Delhi, and did his master's as well from the same institution subsequently. He did MPhil from Punjab University, PGDPA from IIPA, and Diploma in Public Administration from IIPA. He is a certified project management and finance professional from Orwick and Orr, Great Britain, and Manchester and Stern University in New York, USA. Post superannuation, he is on board of many government and private corporations. With those introductions, ladies and gentlemen, let me take you to the questions, to the discussion proper. Yes. And my first query is, what's the pace and status of digitization of static infrastructure of railroads. And may I request Doris to start your intervention?
Thank you, Naresh. Thank you very much. I mean, that's the inconvenience of being a lady, but you always start first. So I'll have a try and try to give the right mood. So first of all, good afternoon, ladies and gentlemen, and I'm really delighted to be here today, just because always the panel that initiated by Naresh are just fantastic, and it's a pleasure being there. And thank you very much to Naresh and to WAPPP for inviting me. I will try from my perspective, because I am a financier, I will try to talk about digitalization from the perspective of finance, because it's my area of expertise. And when you mentioned my CV, thank you very much, you mentioned 20 billion euro project finance. I have to admit that railway weighed a lot in there. And this is exactly the point, because railway project cost a lot. It's not like health or other social infrastructure project. In railway, I mean, it's quite immediately huge amounts. And therefore, from a financial perspective, you've got two pillars to look at. It's fundraising for project and financial management of the railway project. Coming to your question, the pace of status of digitalization, of static infrastructure, of railroad, whatever, I will talk about Europe, which is my playground, I would say, and from the financial perspective. There is a lot which has been done, and when we were preparing the call, I mean, we were reminding that a long time ago, but not so long, there were still a rail crossroad where you needed human operations to just change the line, change the direction. And also the fact that you would not imagine today buying a ticket without digitalization. You're going to the ticketing machine. You're not going to the desk. Also for traffic studies, I started working where for traffic studies, I mean, we were sent as the youngest one to the station, counting the people in the station to know how much people will be there, so that we could do a pretty good forecast. But we were young and funny, and the counting was sometimes quite approximate. This does not exist anymore. This does not exist. When you do forecast and forecast for finance, this is now done by counters, automatic counters. This was the start of digitalization. So there is a kind of bulk which exists for 30, 40 years, and which is quite strong. And there is a part which is new, and I will come back to that later on. As far as financing is concerned, it is, I would say, it's starting. Digitalization is starting in the documentation, and to make the link with the industrial digitalization, technical digitalization of the railway sector. So most of railway projects carry fairly heavy commitments. You've got bonds, you've got performance guarantees, advance payment bonds, retention and complement guarantees, but you've got also exchange rate risk, because I mean, the sourcing of the project is done from multiple countries. You've got high needs of working capital, and in front of this all this financial commitment, the remuneration of the sector is quite low. We are in the low range of the infrastructure sector in terms of remuneration, which itself is remunerated in these days about, in average, 7 to 8% per year. And for railway sector, we're more in the range of 4 to 5%. So it's, I mean, you understand that the cost of the financing in a railway project, especially at a moment where the interest rates are increasing, will have a strong impact either on the cost of the project or on the margins of the company. And this is where we are today.
Thank you. Thank you, Doris. Let me come to Mr. Awasthi. Yes, Mr. Awasthi, what is your view?
Good afternoon to all, and I hope I am audible.
Yes.
Yes, thank you. And hello to you, Doris and Phil. We have been, I think, long back in one of the panel discussion earlier. And all thanks to Dr. Naresh for inviting us. And I only hope that Mr. Rakesh Chopra is able to join, because he has got a lot of experience in this field also.
Yes.
So I will be talking specifically what all has happened in India. So the topic chosen by Dr. Naresh is about static infrastructure. But let me first comment about the other parts. This static infrastructure in any railway segment comprises of around 3 or 4 things. One is track or permanent way, then signaling, and then electrical traction. These are the 3 components mainly. And telecommunication is also there along with signaling, which provides a backbone for various operations. And then there are moving infrastructure also, like locomotives, wagons, and coaches. So these are the 2 components of the infrastructure. And for these infrastructures, operation, running, and monitoring, we have the back office operations, inventory management, project monitoring, ticketing, as Doris mentioned, then operation control center for all these. And so in this regard, let me elaborate that as far as ticketing is concerned, in India, ticketing has been computerized almost in around 1980s. And at that time, it used to have on mainframe computers, etc., etc. And now it has gone far beyond the expectation. Sitting anywhere in the world, I can buy a ticket from my mobile phone for traveling from anywhere to anywhere in India. And even an unreserved ticket in a general bogie, even that ticket can be bought from a mobile phone also. So what the advantage of this is that passengers and customers don't have to stand in the queues to buy tickets, to get reservations, and they can buy it at the leisure of their home. And if they are not educated enough or they don't have the resources, then there are a number of kiosks. Outsourcing has been done. Private person, travel agent also do this for them. Operation part, complete operation as far as India is concerned is actually now is like a centralized control center in the division. And in that we have number of modules. I will not enter into the details of modules. Like for example, for freight operation, we have Freight Operation Information System, FOIS. Similarly, for coaching trains, we have ICMS. Then for actual running of all these trains, there is a control office application which monitors, controls everything. Earlier, there used to be, A0 size printed chart papers on which this train running was monitored by black and blue pencils by the section controllers, but now it's all computerized. Even sitting anywhere in the world, if I have the adequate authority, I can see the train running anywhere in the India. So operation was computerized. Coming to the office processes, the largest application, which in fact not only the Indian Railways, but Government of India by and large employs, is e-office application. So we are now almost 99% paperless working. That means all our files are on e-office. They are electronic files, and they move around on the electronic form through the network that we have. Similarly, for contract management and sanctioning of works, we have what we call Indian Railways Project Management System and Project Sanctioning System. So all sanctioning is done on the e-platform, and thereafter the contract management is also done on the e-platform, including we provide access to our working agencies, the partners, the companies, the contractors. Whichever contract they get, there is a special module for them, and they get entry into that module on our platform, and they can have their complete correspondence, billing, payments, everything in e-form. Even measurement MB is now EMB. It's not in paper form or a book form. It goes in an EMB form. So that whole thing is now on actually the e-platform. And if we talk of inventory, in fact, it has always been world over the easiest thing to computerize. So that's of course there. Talking of now fixed infrastructure, track, signaling along with telecom, and electrical traction. We have almost 75,000 route kilometers and about 115,000 of track kilometers in India. A project was started around 2010. And from then on, complete every inch of the track is now actually on the e-platform called Track Management System. The whole network has been put on that along with georeferencing. I can see it. We have our own geo portal, IR geo portal. And on that IR geo portal, we can see each and every component of the track, bridges, switch expansion joints, fish plated joints, stations, turnouts, everything there. And from that itself is what we have linked is track management system, in which we have complete details of each and every track asset. Now, how this was a huge task in which Mr. Chopra was involved since almost 2005. But when he came to board member in 2010, and that's when he brought me in for this field for computerization of this fixed asset. And if I briefly put it in three parts, when we talk of static infrastructure, first problem that comes is, what is the present status? We have to define what is there in the field in the form of fixed asset into the computer system. That is, what is it that we have and where it is. So the location and what definition has to be put on an e-platform. And thereafter comes whatever we have, wherever it is, what is its condition. So what technically we call, what is the condition data for all these fixed assets. And thereafter comes the monitoring part. We have to, for maintenance of this fixed asset, we have to monitor their condition. So that's where comes the inspection part. So what we call monitoring of condition through inspection data. Now this condition monitoring can be by manual means. An inspector goes, does the inspection, or a machine like a track recording car or ultrasonic flaw detection car or a track geometry measurement car, they go and they do the measurement of the fixed infrastructure track. And then we can have certain automatic sensors which are continuously placed, and they are throwing data to our web servers periodically. We define that periodicity. We want every minute, every 5 minutes, every 1 hour, whatever it is. So these are the three types of monitoring system for the condition data. And from this whole thing, what we arrive at, what needs to be done. That means exception reports or work reports, that which all asset at what all locations require what attention. So this whole thing, as far as Indian Railway is concerned, is on the e-platform. And this has eliminated almost 100,000 registers, more than 100,000 registers, which was the data of these tracks maintained all over the world. Now, what advantage it brings? In that 100,000 register, if the board or zonal headquarter has to get some information, it flows from those registers spread all over the country and then comes to us. In between, there can be a few filters, some wrong data, some mistake somewhere. Now here comes the biggest advantage of computerization is single source of truth. So now whatever data is right from the bottommost ladder of junior engineer to topmost hierarchy member, the board member, it's the same data source which is used and same exception report, same condition. So this is one of a very big advantage, apart from increasing the efficiency and effectiveness, saving time. Now sitting in Delhi, I don't have to ask anybody in the field, send me this data. I can just open my computer, take out whatever report I want. So that's a big advantage, that this static infrastructure, computerization, and IT enablement brings. I can go on, but I'll stop at the moment. Thank you so much.
Thank you. We'll come back to you. We'll come back to you on specifics. Phil, now could you give a global status as you see it?
Yeah, just what's happening, the digitization in railways. I think, as we've discussed, computerization, railways have been big on data, obtaining data all over the world. Huge warehouses full of data that's available. So I want to talk about the operations side of things and as it's coming together. But in an operating environment, as we talked about it, this data comes in, and now we have the ability, and this is developing around the world. We've come from using Morse code in the 1970s and 1980s for train control system to a completely computerized autonomous systems, and it's coming on so fast. We're making these steps. It's not over years and years and years for the very conservative railway operators. This is happening day to day. There's changes. I remember in the 90s when people talked about we were going to be able to monitor the train drivers and how they approached signals and how they moved their trains, and different trains. Every train's different. It's a little easier on an 8-car passenger or 8-wagon coach passenger train versus a 2 or 3 kilometer long freight train. But we were going to have the computer help us with this. We talked about what we were going to do. And then we found out our systems could take in the data, but we didn't know how to analyze it. We didn't know how to assess it. As we go around the world, we've heard the buzzwords now: artificial intelligence, Internet of Things. They're going to help us. It's the big thing. It's what does it really mean? Artificial intelligence, I was listening to a webinar this week, is really machine learning. And we've been doing it since the 1950s when we first introduced computers, IBM, the different big computer systems and whatnot.
Yeah.
Now we've got a word called generative AI. Well, what exactly is that? And people, I can talk these buzzwords, but I'm not a techie to the point where I can get in and start talking algorithms and how it's going to do. But I do know what I want, where I want to get to. And this is what the railway operators around the world are looking for. And then we bring in the financial side of it and how we're going to finance these things as we become more efficient and working things. We're seeing in Africa the development. We're going from narrow gauge railways with no substructure to the potential for high-speed railway connections from Cape Town right up to the north to the Mediterranean. These things are happening, and they're happening quickly. And it's the finance people who are going to look at it and say, well, what can you show me? And I'm an operating guy. And now I can say, well, this is what we can do. This is what we have with artificial intelligence and how it's coming on. The generative AI. I can go to the techie and say, or to the computer now, and say, this is what I want. Tell me how to get there. And that's generative AI. And that's the data. We have the data. But the challenges we have with it is still how much data. I'm working with a company called Aposys right now, Aposys Technologies, small startup company, and they're looking at continually monitoring substructure. And it's great. They did their alpha test on a small railway up in northern Canada, and they're looking at permafrost and whatnot. They did a 475-mile run, and they've got 19 terabytes of data. That's huge, huge. Oh. And now they're sitting there saying, how can we store it? Not only how do we store it to assess? So these are the challenges that they have today. So as we go forward and into this, it's an amazing time for railroads. We can tell people, what the railroads can bring to them in a more definitive manner. So,
thank you, Phil. Now, let me come back to our the safety, because if we are bringing in digitization, improve or assure the safety. So, Doris, Could you throw some light on how digitization is impacting the safety in railways, which is otherwise comparatively a very safe medium as compared to the road travel or any other travel?
Yeah.
So, Doris, floor is.
I would just react on what Philippa just said, because I mean that's so true all about data, and you know that we financiers are already very much under the regulation of data. Finance is very regulated, and modern financiers, they are not as open-minded as we were 30, 40 years ago, because most of finance is regulated by robots. And so you've got to be in the right box if you want to get finance. But finance knows its boxes, but do not know yet the boxes of the railway sector. And this is really key, really key. And I mean, what you said about artificial intelligence is so right. I mean, I remember when I started as a young engineer, I mean, we started coding in Java and so on. So, I mean, all these things about artificial intelligence, it's just a processor being faster, going faster and being bigger. So you got more data, but sometimes too much data kills data. And I remember my dad, when I was a young student, he told me, you'll see, Doris, in the future, they will be the one pushing the button and they will be the one shaping and coding the button. And this is what's happening today. People are using the button, they're using ads, apps. They do not even know what is the coding behind that. And so it's make it very difficult to have several worlds talking together. First of all, technical people between themselves from various countries talking the same language. And we've seen that in Europe with the amortization of the railway network, but it took nearly 30 years so that the people took the same language. And I'm not even talking about the size of the tracks and so on, just about the ERTMS and so on. But that took ages, because people did not know how to connect together, because they had developed their own digitalized standards. When it comes to data now, and I had the issue with a small company I'm working with, which is called Senx, SENX. I will give you the link to their website. The issue I had as a financier in my career is that when it comes to digitalization, God, it costs such a big amount of money, because it's very difficult for technical people in the railway sector to have the same vocabulary as IT people. So they do not define properly the scope of work. So the IT guys, they are coding something, which costs you, because I mean, it's a salary
Doris,
cost.
can I intervene here? Now, when you say there is a language mismatch, possibly it can happen between the IT people and the railway people, how would it impact the safety of the railways? Because if they land up coding something which may eventually impinge on the safety part.
Yeah,
so could you like to throw some light on that?
Yeah, because you've got two parallel works working on their side and providing something which each of them is certain that is going to be safe. And by the end of the road, because they do not speak the same language, it's full of little holes, and it is not safe at all by the end of the road. And this is for me the key matter. After that, you've got all the hijacking on the data and so on, but the higher concern is on the quality and the treatment of the data, to protect the data and the information which is in the data.
Okay.
Very
Thank
true.
you,
And if I can answer to that, when I used to deal with the CFO, and I would be trying to put in more detectors, more sensors on trackside, all right? And my business case was, this will prevent a derailment. The CFO said, well, if the derailment didn't happen, then there's no cost associated with it. And we couldn't put the business case together from a financial point of view, whereas I was doing it from an operating point of view. And that's where the disconnect comes in.
That's the problem.
Yes. Now, artificial intelligence, predictive maintenance, and this is where the safety aspect comes in. We can start predicting failure. But when CN started doing this in 2004, 2003, 2004, a colleague of mine in Chicago was sitting there saying, if I am too conservative, that's great, but we don't move trains. As we know, the safest train is a train that doesn't move. So now we want to move it efficiently.
Yeah, yeah.
And he's
But
trying to.
ships are not designed to be sitting in harbor.
Well, that's right. So, but if you're trying to predict failure, all right, how risk adverse is the company? And this is where it is. Artificial intelligence or big data and the analysis of it, it will not forecast the huge failures and whatnot that happen, but it will help you preventing derailments, preventing failures, preventing like electrical outlets or downtime. There is some prediction involved there. If you get a catastrophic failure, no, that's still going to happen. That happens in every industry. But this is the thing in safety. As we come forward, as we have the ability to start analyzing the data, we can put business cases together to enhance it, to make the railway safer. We can start going away from destructive testing to this autonomous forecasting. So, we do preventive maintenance on the railways. Every so many thousand kilometers, we remove wheels and put new wheels in, whether the old wheels were bad or not. Now we have audio sensors at the side of the track. And it can tell you right down to, you've got 1,500 kilometers left before you have to change that wheel set out. So that I know that I can run the coach or the wagon. It can do another turn with loads or with people in it safely. So these are the things that it brings to us from a safety point of view. The digitization, the digital twin development of the railway infrastructure. As we get better at that, we've been doing it since the 1990s. Developing it, we're getting better. We're bringing in satellites that are looking at it and giving us, so we get a true digital twin. So that's the safety. I'll pass to the next.
I think,
Thank you, Phil. Now, let me welcome Mr. Rakesh Chopra, who could not join initially. Now he's with us, and I have already introduced him. Now, straight away, I would request him to give his view on the safety after digitization, the topic which we are currently right now discussing. Over to you, Chopra sir, on the safety with digitization.
Thank you. I'm late. Good afternoon, good morning to everyone, and nice seeing some of the old faces there. I'm sorry I haven't heard most of the discussion, but I'll go largely in a very short time on safety. And Mr. Avasthi is sitting there, him and I actually, he was my head of the implementation team on the Indian Railways when all this work was done there. Safety improves. And I was just hearing the last speaker say a lot about getting the data and being able to forecast. There, I'm not too sure if that is going to be a possibility with the probabilities that still exist and maybe with the data that we have. So anyway, I still feel that the very fact that we do the digitization, and it's also important to get into the digitalization, because what is beginning to happen now is that the structure is there, but we have to start measuring the parameters, and Indian Railways have been doing measuring those parameters. Now, the point is, along with AI, AI has not yet been applied as yet very extensively, but along with AI, the forecast could start. Now, my belief is that forecast is not going to stop accidents. I'm being very blunt about it. Forecast is not going to stop accidents. But the fact is, it is going to lead you to reduce the number of accidents, and also the fact that since it is a real-time information that is being collected, analyzed, and examined, the possibility of prevention certainly goes up. So that is a positive in the safety itself. Now, this is not only in the particularly in the track where the real-time dynamics is very, very high. I look at it this, and that is what the Indian Railways have done. We have got plenty of it on the bridges also. And some of our bridges are more than 100 years old. So I think the application of AI there, along with the data that we have collected, would be much more helpful than alone on the track. I mean, that's what my thoughts are right now.
You're right, sir.
Thank you, sir.
And I think what Doris mentioned about the finance part, because the railway infrastructure asset digitization and what benefits it will bring, she was very right when she said that the finance man doesn't understand. And that's where
Can I just come in here? Sorry, it's Mr. Avasthi speaking.
Yes, sir.
Carry on, Avasthi.
Yeah, so at the same time, what Phil mentioned, that by deploying this digitization and analysis, and which helped us and which reduced the accidents or maybe brought it to zero, whatever it is, then after a couple of years, finance man said, why should I put in so much of money here? Nothing happens. Everything is all right.
Yeah.
Everything is all right. Right. So here I would like to elaborate something. Like earlier, we used to have what we call periodic maintenance. Do this thing once in 2 years, do this thing once in 10 years, do this thing once in 5 years. I mean, that's where actually the financial numbers are helped. They are the whole digitization and using this to land up in the condition-based monitoring and maybe initially corrective maintenance based upon the condition, not based upon the periodicity. That brings in some saving. So finance man is happy with that. And the next step comes the predictive maintenance. As Mr. Chopra mentioned, AI has to be brought in here. So let me elaborate, mention for his and everybody's information that it calls for extensive modeling as part of AI to use the predictive maintenance. For example, using the track geometry data in 3-axis X, Y, and Z, we have developed certain predictive maintenance model. If today this is my track, and in previous 3 recordings, this was my track, and then we build a model and extend it to in say 3 months hence, 6 months hence, where my track geometry will land up, and exactly what time I should deploy the track maintenance machines over this section. So that brings in definitely efficiency, cost saving, better track quality, as well as it will definitely help in contribution of track in improving safety. I'm saying contribution of track because rolling stock plays also a very important role in safety area. So, I mean, that's what the thought came to me based upon what they said. And another very important thing which Doris mentioned was there's the person who is doing coding, and then there's a railway infra man who doesn't understand it. So, which basically means if a railway infrastructure man has some knowledge of application designing, that's a best combination. Means the domain person has to involve with the application designer and coder to arrive faster at a better application. Incidentally, I will give credit to Mr. Chopra. I don't know from where he picked me up. Probably he knew that I used to do coding in college and thereafter also. I did coding in Fortran, Basic, Pascal, C++, Visual C++, and he got to know somewhere and he put me, now you develop it because you know the coding part, application designing part also, and now you are a railwayman, so do it. So that's a very important point actually which Doris mentioned. Domain person has to involve, and 50% responsibility, rather 70% responsibility rests with him, along with the coder to have faster and a better IT application for asset computerization. Am I right, Phil?
Very much correct. I love when you talk about the periodic maintenance and what we used to do and what we can do today. And if you don't have to put people out on the track, that in itself becomes a more improved safety environment. The other thing, and this leads right into the efficiencies gained by digitization.
Well, can we also focus on the profitability as we are talking sometimes, but efficiency and profitability also we need to focus on.
Well, and that's what I was just bringing
Please.
in. So if you can reduce, one of the problems we have today is getting qualified, trained track inspectors and that sort of thing. They've become entry-level jobs on the railroad, and you can't get people to go to remote locations. So, you know, the regulator says track has to be inspected so often. And that will be here for a while. The regulators are very slow to change. But as we bring in the digitization, the ability to look at it, over time, it will be seen that autonomous track inspection, infrastructure inspection, whether it's ground penetrating radar, LiDAR, photographs, that's going to be better. It's going to be safer. It's going to be more efficient than a person out there riding on a high rail truck or walking. You know, you can't tell me that a person going along at 15 kilometers an hour is going to pick up every defect in a track. And now we tell them that they have to work at nighttime because passenger trains and freight trains all run in the daytime and it's very busy. So you'll have a window of opportunity between midnight and 4 a.m. And that's when you get out there with your big lights. As we get into our monitoring, autonomous monitoring, this will benefit because we'll be able to see, we can actually put a cost savings to that and the efficiencies gained. We'll see safety improved, and that's going to be data over time as it comes. But what we're going to take is, it's not we're going to reduce people so much, but we're going to remove the mundane tasks that we expect people to be doing. Today, a track geometry car will go over the railway track, and then we hand the track inspector or the roadmaster or 2 feet of paper that he's got to look through and understand while he's doing his day job. So these things, we're going to have dashboards. The dashboard's going to identify, but we have I'm going to get into this a little later on, but we've got so many dashboards now. We're going to need artificial intelligence to assess the dashboards to give people the information. So, but this is on the efficiency and profitability. As you know, again, you're going to have the labor, you're going to have the improved inspections, the digital twin, how you're going to operate to have your, if you're an electric railway, your power draw, when's the best time, how to draw, how to redirect power to it. This is the data is there now. We know it. Intuitively, we know it, but it's as we get the ability to write the algorithms, and it's it's generative. I think it's going to be the generative AI. It's the computer that's going to teach us how to read this information, what data is important. So,
very good, very well articulated about the digital part. Mr. Chopra, sir, would you like to come in here? Mr. Chopra? Mr. Chopra, can you hear me? You are muted.
Yeah, okay, sorry. I've unmuted.
You are muted
myself.
You please.
Yeah, I'll just take a while. Now, this is on the profitability. So the way I look at it is that it's the way we look at profitability. That is going to be the proposition. And the first part of the profitability really is derived from the fact that at least on the Indian Railways, we had a time-based renewal of assets. It was based on time. So there was a lot of asset which probably could have been used, and not that we were not using it. We were taking it to the lines which were running with a lesser traffic density, using it there. But the fact still remained that there was a time loss in the renewals that were taking place, including the new asset. So the first great thing is that you can certainly start postponing that, delaying that, or as a matter of fact, gaining a lot out of that. That is one part of it. So the profitability aspect is there. It requires to be examined in much more detail, but with the data that is available and forecasting that can be made on safety, considering the range of safety that we are going to be working on, we can certainly improve upon that aspect. Secondly, there will be a reduction in the manpower. There is no doubt about it. But I slightly, I'm I'm not against AI, or for that matter, even, I mean, I think people like Avasthi may not agree with me. The fact remains that depending too much on data and depending too much on forecasting and not having inspectors available in the market is disastrous. So we have to have inspectors who, even if we have AI running and a data and a forecasting going on, who have to be in the field. They have to keep themselves acquainted with the field very much, with the asset in the field very much, have the feel of the asset. Because the fact that remains is that if we get away from it and get onto the computers and the air-conditioned rooms, tomorrow there's going to be a situation when the inspector will not know how to repair it. And that is going to be taking a lot of time and will be wasting a lot of money. And as a matter of fact, correcting. Now, this is a case which has happened in India. We have seen that in a situation, I'm not talking of the railways, we have had a case in the tunnels, in one of the construction projects, where what was being started was without actually having a full benefit of the trained engineers and people, assisting them there. And the contractor did not do that. Uh, Consequences were that when the tunnel collapse took place, there have been very serious consequences of that. Fortunately, no one died in that, but the delays were large and many. So the same thing can happen. Same thing can happen on bridges. I'm more concerned about the bridges because we have been looking at pre-stressed concrete bridges in a big way. And we have installed a lot of those bridges there. But heavens only know how to inspect these bridges. The best of the engineers, I mean, all the methods that are there in the British codes or the European codes or the American codes or the Indian codes, they do not let you know when the fracture starts. Leave aside the steel bridges. Steel bridges have a story to tell. They tell you a happening that takes place. It's a story you can read. Concrete bridges, you can't do that. So it is going to be a mix of a game. But the fact is that, yes, if one looks at the profitability, there will be profitability in the ordering of the asset that is going to be required, be it a wheel, be it a rail or a signaling system, the wires or things like that. But I slightly differ if you are going to leave entirely to the game to the people who are going to be only getting up from the computers and going and into the field and repairing on the basis of some abstract random forecast. That is not going to work. Thank you.
Thank you, sir. Doris, you want to come in?
Yeah. I mean, I do concur totally to what Mr. Chopra said. And I would like to react again as a financier. Finances, we do not like surprises, not at all. And namely in digitalization, there are 4 surprises we do not like. The first one is to discover a new cost for query for questioning data. The second one is facing evolution of IT system and digitalization. I mean, in my career, each time I have been putting in place an IT system for the company, for the railway, for whatever. I mean, a couple of years after, I've been told that the system was too old and we needed a new one. So that's an issue. The third surprise I don't like is to discover that we have shared the data with the competition. That's an awful lot because it became open to public. That was open data. That's so cool, open data. But sometimes, I mean, it's so open that you're giving your books. And the last one, which has been mentioned by Mr. Chopra, is, to my mind, digitalization at some point of time kills the human creativity. And namely, that's the limit of artificial intelligence, because it gives you access to some of the books of the bookshop, but not all. You've got always the same big books in front of you, but to find the tiny one which helps you, it's very difficult because it gives you access to always the same information. And you know that the railway sector, in the railway sector, we are basically in a buyer market. More than in a seller market. That is to say that the advantage is on the side of the buyers. It means that the number of the goods for sale is greater than the number of potential buyers. So in such case, buyers have more choice. They are in a position of trends, and prices tend to be negotiated downwards, and the terms of payment are quite harsher. So all this to say, and to make the link with production and maintenance, and that each negative event of a project has a negative impact on production and maintenance. This is why we are so keen on protecting production and maintenance items, and why we are trying to use forecasted to use that, because they will have a significant impact on margins. And what makes the situation worse is the delay in resolving the problems. So this is where we will see that the digitalization will have an impact. I will give a concrete example about equipment maintenance, still from a financial point of view. Digitalization allows substantial savings, as we said, through connected sensors and preventive maintenance. We are at the era of IoT and time series, which is data in real time, and also from industrial Internet of Things, which refer to the application of the IoT technology in an industrial setting. And all these are developing very fast in the railway sector. We are collecting more and more and more data, both on the running stock, on the superstructure, on the infrastructure, on trains, whatever, every kind of data everywhere. And we have even real-time data from the captors with the captors that can be used to measure the performance, the state of equipment, whatever. To the extent that we've got so many data that it has a cost of stocking. If the data have not been formatted in a particular way, you can ask them only one question. So, for instance, if you got a track with a wrong signal, you say, "Oh, it sends a wrong signal. Why? Is it the sensor not working, or is there an issue with the track?" And then you do not know. You need to ask another question to the system, and then your IT guy say, "Oh yeah, but the infrastructure of the IT is not done that way. You need to put another 50 million euros on the table so we can ask the question." And this is the difficult part. So there are some companies, just like the one I mentioned, the Thanks company, where they are, and this is where it will be very interesting. There are tools, new tools, coming to deal with huge number of time series data without adding this extra layer of IT infrastructure. And with this type of tools, yes, you can improve your performance, you can significantly reduce your performance cost, but also you can make multiple queries and keep your human ability to react and solve a problem.
Okay, thank you,
Good
Doris.
points. Good
now
points,
let me
Doris.
go on to
No, I said good points.
Yeah,
Doris has made very, very
thank
good
you
points. Yeah.
for making such wonderful points. Yes. Yes. So let me steer you all towards looking at the challenges which are thrown by the digitization. So let me ask Mr. Avasthi, what has been your experience and what you look at when we talk of challenges?
The biggest challenge which I find is management of change. Management of change of mindset. A person is tuned to record his inspection, condition, observations in a paper, on a register, by his pen, and suddenly he finds this is all old. He has to do the measurement with some electronic devices which will throw the data directly to the server, or maybe he has to record his observations in computerized applications. So management of change, and that change actually requires a lot of personal contact by the trainers. So that involves a lot of training, persuasion, convincing the field people that it is for their good, show them the benefits that it is going to bring to them, how it will facilitate their working, how it will remove the mundane part of their working, and how it is going to increase their efficiency, how it is going to increase their effectiveness, and how it is going to make their life better. That's one part. And definitely it, of course, calls for initial capital investment of servers and what Doris mentioned about GBs and TBs of data, and then the IT guy charges money for that. And incidentally, just to mention, somehow an engineer of railway asset maintenance is not paid that much as an IT guy is paid. That's the, that's the truth of the world.
That's interesting.
So,
Now,
and then
I request Mr. Chopra. Yeah, please. If you wish to continue. Otherwise, I would request Mr. Chopra to come in.
another challenge which I find, is this all requires a very strong communication backbone, right? And for example, now we have in 5G mode, or maybe certain railways, certain infrastructure companies have their own optical fiber cables laid along, or maybe microwave towers. But a good communication backbone is required. Like in India, we have stretches which are still running on 2G. So there things are so slow to upload the data and download the reports and see the condition. So a good communication backbone throughout the network is a challenge.
Thank you. Mr. Chopra, would you like to elaborate or comment on that?
Yes, I'll add. As a matter of fact, today on the Indian Railways, there's nobody better experienced on implementation than Mr. Avasthi. So some of those challenges, that he has told you, he has gone through those challenges, and I have seen him go through how he managed. Having said that, I think the management of change that he has spoken of, that was a great challenge. But today, the youngsters who have come in and now today who are holding positions, senior positions in the railways, they are very familiar with these technologies. And as a matter of fact, they have become so familiar that they prefer these technologies because they allow them to be working on the air-conditioned rooms. So that change was a big challenge. Certainly during when he was there and I was there, it was a very big challenge. And a challenge to the extent that at the level of the chief engineer, head of a zonal railway for engineering, where this data was going onto his computer on the office table, they would actually shut it off. They did not know what to do with it. And if something was showing there, they would shut it off. That is one part of it. Coming to the financial challenge, I agree with what Doris and Philip have in mind, because Philip is from an area where there is a private railway system. Doris is also talking of European railway systems where there is a lot of private railway system. Fortunately, in Indian Railways, it is a big, large organization. So, for us, we did have difficulty in convincing the finance, but once we were able to put across the conviction, then getting the finance was not. As a matter of fact, it was peanuts for us for the big budget Indian Railways had. That was not very difficult for an organization like the Indian Railways, which is rather large. But of course, I agree that for private organizations, the point that Doris has made makes the thing right. The third point that I'm making is I'm taking an example of the passenger reservation systems on Indian Railways, which is massive, and it came about 3 decades or more than 3 decades back. It is actually a fear we have in mind that the technology or the development and the changes in the technology will not get adopted. As a matter of fact, the basic layout and the algorithm that
Did we lose him?
I think he got disconnected, it seems.
Lost him.
There he is. He's coming back.
Oh, okay. So he's coming in. He's coming. Yeah, he's here. Please unmute yourself, sir. You need to unmute. Mr. Chopra, you have to unmute, sir.
Yeah, I'm sorry. I'm not on my PC. That the Zoom didn't just take off. I don't know what happened. I had to come on my phone. So what I was saying was that finance, number one, is that finance does not become a big problem for an organization like the Indian Railways. They can take it on. But what I feel is a great challenge is the interpretation of the data. The standardization of the data projections that are going to be there, and the people who are going to be accepting it subsequently and taking actions on that. Now, that has still not happened on the Indian Railways, and that is still being looked from the codal provisions that we have got. We are still going ahead with renewals based, despite this data, based on age in several areas, So that changeover, to take advantage of what the forecast is telling you, is getting very difficult. And the reason for difficulty is that what we are finding is that sometimes the stretch of defect is much smaller, and the small stretch of defect, if you take it up for maintenance or a renewal, costs much more than probably a longer stretch that has to be replaced. So this is a challenge that is being faced today. And probably over a period of time, this would also need to be overcome. Thank you.
Thank you. Thank you, sir. Well done, well articulated on that. Phil, you'd like to come in? You are raising the hand.
Yeah, well, challenges.
Yes.
Yeah, as we've heard from everybody, I had a number of points on this one, but I want to start out. You need buy-in from the top, as we're basically talking about, but they have to listen from the bottom up. What are we digitizing? What tools are we giving the people? Granted, we still need the human contact out on the infrastructure. We need people who are experienced, but we don't have the experience. The young people coming up, they're good. I don't want to take anything away, but the he's been out there for 40 years and he's got a hammer and he's got a pick and he's started with wooden sleepers and he's now into high tech. We've got to be careful. We've got to make sure we're giving them the proper tools out there with digitization. We've got data fatigue can become a problem. And as I talked about these dashboards, they're going to be great. They're going to highlight things, but we still need the person who I used to say can go out and kick the tie plates. Who knows what's going on? Now we have another challenge too as we go forward. Things are moving so fast that the finance people, because we are PPP oriented on this call, get really upset, as Doris mentioned, when you have a system that changes or a system can't handle what you want to do. So right now we talk about ERTMS and how great it is. And it's a fabulous system. It was started in 1990. It's 1G. GSMR is a very antiquated cellular phone system.
And we are already at ERTMS level 3.
Yeah, well, level
1, 2, 3, and it's still not.
It's still GSMR. Okay, so the ERA has come up and said, well, we're going to study this starting in 2025. Okay, for a correction or a fix by 2030. The Koreans wouldn't wait for that. They've got what they call, instead of ETCS, FTCS, Future Train Control Systems, using 5G technology. This is where we have to go. We have to be able to adjust and keep the finance people happy. It's always got to be going forward. The other thing I wanted to talk about is just sheer size of systems. North America has 300,000 kilometers of route miles. Europe has over 250,000. India, 115,000. China is even bigger. So what are we going to do? How do we standardize this? Making sure the data is coming in without giving away trade secrets, as Doris mentioned. You don't want to be giving, throwing the baby out with the bathwater, as they say. But we have to be standardized. The regulatory groups have to accept the data changes. The operators, the infrastructure owners have to identify that this is a better way to go. But if I'm doing it my way, I have to be interoperable with the others. Now, the ERA has handled that quite well. India, a huge system, it does come under one regulator. It's one company. So they have it a little bit easier. But we still have to make sure that we can trade information, that how we collect data, how we assess data without giving away the bank, if you will. So these are the challenges that we've got. So we'll get there.
Yeah, that's very interesting because it gives the value of the data. What is the value of the data and are the data tradable? And we are coming to blockchain in a minute, I think.
Yes. Yeah. And that may be the way, is blockchain the answer.
Yeah. Well, good that you mentioned. Mrs. Awasthi, you'd like to talk about anything on the...
Yes, two things. With all this, we are so much dependent upon technology. Our systems working, servers working, communication backbone working, laptops working, iPads working, field phones working. If something in that chain breaks, the problems come. So upkeep of that, all components of that technological change is also a challenge, actually, one. Secondly, what Phil mentioned about the security of data, which basically means cyber security.
Mm-hmm.
I mean, it is one of a nightmare these days, one of a nightmare. I mean, if the whole operation is controlled by the system and then cybersecurity breach is there, it can play havoc. So that also needs to be addressed and kept in mind while designing the system, while designing how we isolate it from outside world, and at the same time, the efficiency is not compromised. That's another challenge.
Okay, panelists, now we have almost completed the discussion part and we have some queries and questions. So if you agree, I can start with that. And the first question is very interestingly about the human creativity challenge, which I think Doris mentioned. So there's it has been asked that could you elaborate on that, maybe from safety and efficiency point of view.
Well, I mean, the first limit is quite often the system are put through tender processes, and when the tender processes are digitalized, you got a right to answer by a kind of yes or no question system. And sometimes you've got the right in the system to answer to tender to 30 or 40 characters full point, which prevents you of giving a nice idea. Sometimes there is no room for options because the tender process have been digitalized, and you cannot answer anything else than yes or no. That's the first one coming for me as a limit. The second one, that's mostly for the creativity part on the tenders and on the process. But when it comes to solving problems, when everything is digitalized, you can get only the information that have been recorded. And then finding solutions might take longer than if you have nothing recorded. Because when you've got nothing recorded, you make the audit of the problem and you try to find the solution which is the most adapted. I had the issue with one infrastructure project. It was not in railway. It was in real estate, where the grantor has decided to have all the stakeholders using one application, which was collecting solution for typical problems, and all the guys agreed to use the apps and so on, and they put all their daily lives on the site in the apps, and that was very well. And we had one problem. The problem was not registered in the database, and the guys were lost. So the grantors say, okay, put that aside, come back to the old manners and find a solution, because we need to have a solution. And this is for me where, I mean, we become lazy. The more the work is facilitated by digitalization, the more our brain is lazy, and the less quicker we find solutions.
I think very well identified. I think Mr. Awasthi is raising hand. Would like to add anything here? Mr. Awasthi, you have to unmute yourself. Your hand is raised.
No, I forgot to lower the hand, actually.
Okay. Anyone else would like to add here? The human creativity part of it, how it gets challenged and may impinge on safety or efficiency?
I think that's yeah, very careful of. I think back of times even in the past where it's the person who goes out to assess the issue or assess the problem identifies it through something totally different than what you would normally have looked at. That's either experience, just being in the area, as Mr. Chopra mentioned. You need that old time experience. We don't have that now.
Yeah.
We don't have a person who's got 40 years experience. So what can digitization assist that younger person coming in, so that when he is out in the field, we don't want people in the air conditioned offices. We have to have people who understand it from the bottom up. They can get their hands dirty. I think it's very, very important.
Yeah.
If
The
I
next
may just,
question is about yeah, come in, sir, please.
No, I was just mentioning Mr. Awasthi. I would take him there because, see, again, a small advantage that Indian Railways have been following, and which actually the practices have been picked up from all over the world railways. But we have an organization which has been constantly and regularly updating. I mean, for instance, the very fact that we went from wooden sleepers to concrete sleepers, or to LWRs, long welded rails and continuous welded rails, there were technologies that were coming. Now, those technologies had already got adapted and adopted into our codal systems and practices. Now, here, Philip, what I'm trying to say is that these practices did exist in our books. And the algorithm which was made out for the systems that we started initially, of course, there were a lot of changes which were done subsequently. These algorithms were made on the basis of systems which had been laid down, which had been ingrained in the mind of the people and embedded in the back of the head. Those systems, Indian Railways still continues to teach. I'm just saying that for the future also. See, whoever is going to be there, whether it is in a private organization, they're going to be contractors and contractors men. There was a stage where for our contractors who are dealing with the railways, particularly the renewal, track renewals, or bridge works and things like that, the Indian Railways, they started actually giving courses to those people there. Now there is an organization, there's actually a big company called Larsen and Toubro in India. They do a lot of work on the railways. As a matter of fact, they have opened up a beautiful school for the training of their people there. So what is beginning to be seen, and there I find a lot of creativity, because those are minds who have not been working for the railway. They have been taught the railway, and they have been taught the computers. When they sit on it, they do come out with some challenging solutions sometimes, which may not seem practical. Absolutely, which may not seem practical. So that is the type of thing that can happen. That is certainly there, and to create a change, I think that is where within the system again, that is going to be a big innovation that is going to be needed. Create a change in what is going on. How rapidly you're going to do that with the technology that is coming in there. Technology cannot be put, sorry, I'll just take a minute. Like, from 2G to 5G, we just can't make a jump. From 2G to 5G, in a system like in India, we have a problem because, as Avasti said, we have 2G still going on somewhere. We got 3G, 4G, and 5G at a little place. So that is a big problem. But still, how these people are able to use that and sit in their head offices and get that information with the time pass also, that is what is another innovation.
Sorry, go ahead, Doris.
Can we move into the next one? The next is, ladies and gentlemen, all of you have flagged the issue of inspection, monitoring of track, and Phil even said that the qualified trained track inspectors are deficient. So how does this aspect get helped by digitization, or also may pose a challenge in future by extra digitization or use of AI? I mean, it has both sides. So the question is on that. That could you elaborate on that?
I'd like to point out. I don't think the track inspectors are deficient, but I think they lack experience out there and doing eye inspections. I think digitization is going to bring it to a new level. But where the training and whatnot that we have to give these people, I think Mr. Chopra hit it. What's being done out there, the training is fabulous. From the old days where you gave the person the pick and said go to work. He was fresh out of high school, if he even had high school, to now we have technical engineers going out there and doing these jobs. I think, but we need change agents. We need people at the top who listen to what the people at the bottom need. You can take all kinds of systems and put it out there, but if they're not applicable, it adds to the data fatigue that we're pushing on people. This is where we have to be very careful, that we implement the proper systems. We're giving the right data. We're removing the mundane tasks that people have to do today. Let the computer do that. But the people who are working out there, we have to let them still be innovative. They have to still contribute. They don't have to follow with the computer. We still have to control what the computer is telling us to do. And that's important, I think, going forward.
Yeah.
Very important. Very important.
The last point which is raised here is that since the entire railroad system works for that user or that freight, now considering from a passenger point of view, do you feel that the digitization is adding to the safety of the passenger movement and efficiency of the overall operations, and certainly the profitability wherever it is required? Mr. Chopra.
Yeah, I think so. I think all three factors that you have mentioned, it certainly is. Nobody can deny the fact that having digitized or the digitalization that is going on. See, the point is, it is not only digitization. The earlier point that you had mentioned about the maintenance, the inspection and maintenance, I'll just elaborate a little bit on the maintenance aspect. So what has happened is the mechanization of the maintenance has taken place in a big way. And well, in that regard, again, Mr. Avasthi has been a partner with me. We really have got into the mechanization. He can tell a lot more about that, also implementation of that. But today we have a lot of machines. Now, what is happening with these machines is whether they are giving you the required, the end result or not is not being checked. So having a digitization, it would mean, yes, I need to maintain a particular stretch of track. So what do I need for that? I need a particular tamper. I can send a tamper. It doesn't end there. The point is the tamper actually giving me the results that I want? And how is that result going to be measured subsequently? And what is going to happen with that? That is a challenge today. That aspect is the challenge today. Mr. Avasthi, he is a youngster. He's worked more than, I've retired last 14 years. He can probably tell you what is the latest, but I feel that danger is still existing on the Indian Railways.
He's also retired, sir.
I know. I got to know, as a matter of fact, I'll talk to him later about that. But what I'm saying is, he's been a youngster. He's worked more than, the later years when the computerization and digitization came for a longer period than I have worked. So these are my views. He can probably either accept or reject or change them.
But Mr. Chopra,
actually, sir, I mean, this reminds me of what actually Philip said earlier. There is no substitute to a good field engineer. There's no doubt about it. Only thing this digitization does is that removes the mundane work, mundane paperwork of the field engineer and makes his life easy and more efficient, right? I'll just give you one example, sir. When I was in the field at a field engineer at a much junior level, I had to inspect my complete section once a month with my eyes only, right? Means physically I have to inspect every section. Now with all this computerization, digitization, monitoring, data coming in, now that periodicity of inspection at that level is now once in 3 months. It is not that as a field engineer, I don't have to see it. I should see it, right? There are certain experience of a field engineer is sometimes cannot be replaced absolutely by the digitization. So that definitely remains, and that should remain also. But yes, it should facilitate, it should help, digitization can give a field engineer a precise data that, as per me, these are the certain locations which need to be inspected by you in detail. Consider various factors in the field, which may be geology, which may be drainage issues, which may be many other issues. Combine all of them and find a good solution to it. Rather than he going ab initio without no data with him. And sometimes, you know, after all, field engineer is a human. Certain details may get missed out also by his eyes. So that's where these things help actually. And what Mr. Chopra mentioned about tamping work, yes, if with all this efficiency, precise deployment of track maintenance machine is done, but if that machine doesn't give quality, I mean, it's a challenge. Yes. But there also we have certain sensors being placed in the field. Like track machine today has a sensor for squeezing pressure. It has a sensor for penetration depth. It has a sensor for 4 important parameters that actually gives a good quality. So there also, sir, things have come in. The IT part has come in there also.
Wonderful. Thank you. Thank you, gentlemen. We have almost completed the time. And we had a very lively discussion. And I'm sure our viewers have also been enriched, and that is reflected by the questions they have raised. And I would specifically mention there are issues like human creativity, which got discussed, which is importantly raised by Doris. Then Ms. Chopra gave the example of the PRS, and Philip brought in the discussion of digital twin among everything else, and interoperability and standardization. And Mr. Avasthi was talking from his experience throughout of digitization of the Indian railway tracks. And we discussed various types of challenges. And with that, I must thank our viewers and the number of professionals who have joined us in this webinar. We thank you all for having taken the time to participate and for the interesting questions that were addressed to our exceptional panelists. We'll shortly publish a short summary of today's webinar on our website, and the recorded video will be available on our YouTube channel and on LinkedIn. And I suggest you don't forget to listen to the last episode of WAPPP, which happened just a few days back, and keep a track on our other contents which are coming in our YouTube channel. And thank you very much, and have a nice day or evening wherever you are in the world, and a very respectful namaste from my side to all of you, to our panelists. Thank you very much. Namaste.
Thank you. Thank you. Thank you, Doris. Thank you, Philip. Thank you, Mr. Avasthi and Colonel BANA. Thank you very much for getting me to meet Doris after a long time and Philip after a long time. God bless you all.
Thank you.
From India, good night, I'm saying. Good night from India.
Be safe, everybody. Thank you.
Yep.